welcome to Google Open Source Live. We're excited to have you here and to share a few things with you about Go. I'm Matt, and I'll be talking a bit about Go as a language and why it's a great fit to build fast, reliable, and efficient software at scale. Then my colleagues Steve and Carmen will cover the most common use cases for the language. So let's get started. So why choose Go? Let's start with the basics, covering the foundation of the language, and give you an idea of what to expect when using Go. At a high level, Go is designed to be simple and reliable in the era of multi-core computing. It's easy to learn and get started with many developers becoming productive in just a few days and sometimes even hours. Go is also a cloud-native language designed to operate at scale. It was built with microservices in mind, and its standard library and performant design make it perfect for large distributed systems. And Go has a thriving ecosystem with a growing set of partners, communities, and tools. Gophers around the world are constantly adding new packages, organizing events to share knowledge, or contributing to the core language. And if you're new to Go, chances are there's a Gopher out there ready and waiting to answer your questions. These three pillars of Go, simplicity, scalability, and community, make working with Go a great experience. So let's take a moment to talk a bit more about the language itself. So what makes Go great? As a language, Go is everything you need, right out of the box or binary. And that starts with its robust standard library. Go's standard library is incredibly comprehensive and of excellent quality. It's extensible and includes packages that cover the basics of almost any project. From building web servers with Go's built-in high-performance HTTP package, to handling files and other programs, to managing encryption with the crypto package. For whatever you're building, chances are there's a package or two in the standard library that will help. Go also helps keep things maintainable with automatic formatting and documentation, and this is in addition to Go's syntax that focuses on readability. Many projects are built solely relying on the standard library without having to look elsewhere for support. And while the standard library is expansive, if your needs aren't met there, there's definitely a solution in the ecosystem. Now let's talk about building with Go. Building with Go is easy. When working with a language, every Go program compiles to a single binary, including any system code required to run it, which keeps things simple as projects progress in complexity. And as they progress, you can leverage Go's built-in concurrency mechanisms, or Goroutines, which make it really simple to build concurrent programs, all while taking advantage of Go's fantastic memory and CPU management and instant startup times. Additionally, Go's dependency management is tightly integrated and seamless. With modules, which we'll cover a bit more in detail later today, Go helps you keep packages secure and compatible, helping you avoid the diamond dependency problem and dependency hell. And to top it off, Go is supported by the Go team at Google, who work every day to continue to improve the Go experience. From leading our biannual release process, to directly triaging security reports, to working collaboratively with the contributor community to ensure feedback is front and center of the development process. And their work leads to great results for all Go users. Just recently, in the latest release of Go 1.15, we saw a sample of Go programs compile around 20% faster and take around 30% less memory on average for all projects, but especially large distributed projects built in Go. That can lead to a solid reduction in compute costs. And this is just one example of many changes the team has worked on and will continue to work on with the community's help. This kind of performance increase, 15 versions in, is what the team aims for with every major release. And as we continue to improve the functionality, performance, and productivity of Go, we make sure that every Go program, written since the original release of Go 1.0, will compile with newer versions up to our latest release. This is our 1.0 compatibility promise. It's awesome. And it's part of what makes Go so easy to maintain. So let's take a step back and look at the ecosystem, which continues to grow with more developers using Go every day. Just to get a quick sense, we took a look at growth in pull requests of Go programs on GitHub. Over the last 5 years, that amount has nearly tripled, and it continues to grow. Additionally, several surveys cite Go as the #1 language in several areas. Go shows up as the top language that developers want to learn, and also as the top language that developer teams are looking to adopt or migrate to. Go also shows up as the highest paying language and the language with the most demand from employers, and this comes as more companies are increasingly seeking Go developers. In short, it's a great time to be a Go developer and a great time to start building with Go. And when it comes to building with Go, many companies around the world use Go and are often sharing their insights with the community. PayPal, Facebook, Microsoft, Mercado Libre, Netflix, and many more companies are using Go. A great example, which you'll hear much more about later today, is Khan Academy, who began migrating their infrastructure from Python to Go and have already begun to see the benefits of doing so. And of course, we use Go here at Google. From the web indexing pipeline that powers Google Search to the backend of Firebase hosting, which powers thousands of websites around the world. We also use Go on teams like Chrome, messaging, and many more. And in line with companies using Go, we're seeing folks choose Go to build software in the cloud. And the three pillars of Go, simplicity, scalability, and community, are the reasons why many of these companies keep choosing Go. If you want to learn a bit more about who's using Go, how to get started with the language, you can visit go.dev. Finally, I wanted to touch on the community, which in many ways is the beating heart of Go. The community is what keeps Gophers active, connected, and up to date on the latest changes with Go and related tooling and support. The community also actively contributes to Go releases, helping the Go team at Google make the best decisions for the ecosystem. To get a sense of scale, today, the Gopher community has grown to reach over 180 groups in nearly 50 countries. These groups host events almost every week and are now doing so virtually. Over the last year, there have also been 32 conferences. One conference is taking place very soon. Just next week, many Gophers will be attending GopherCon in a new all-virtual experience. The Gopher community, whether it be meetups, listservs, or smaller groups of developers, are all enthusiastic and inspiring. Joining one is a great way to meet other developers, jump into Go, and share your knowledge with others. The swag is pretty cool too. So I've talked a bit about what makes Go great, where the language is heading, and who's using Go, ranging from individual devs to enterprises. I also touched on the community and how Gophers around the world stay connected and informed. Hopefully this has helped you answer the question, why Go? But to take it one step further, my colleague Stephen Carmen are going to cover the top 4 use cases for the language. These are command line applications, APIs, web apps, and DevOps. So take it away.
Go is a great fit for command line or CLI applications. Over the past decade, these have made a huge comeback and firmly have a place alongside server, web, desktop, and mobile apps. With CLI applications, there are a few factors that are really important. You want the application to seamlessly work cross-platform. You want the application to load instantly. You want it to be easily installed and updated without local dependencies. You want the app to have good performance, and you want it to be easy to write an app with good usability. Go checks every box. Go natively supports every modern operating system and architecture and many legacy ones. Go makes it trivial to build Windows, Mac, Linux, etc. versions for various architectures right from your development machine. Most applications build around 1 second. For anyone who's used C or C++ based applications, this is unbelievably simple. Go applications have 0 dependencies on the host. There's no fighting with incompatible libraries or runtime versions, and no runtimes or interpreters to install. Once the application is built, installing it is as simple as copying a single file to another machine. It just works. Compared to Java, JavaScript, Python, Ruby, and even C-based applications, this is incredibly smooth. Upgrading is just as easy. Simply replace the old file with a new one. It's a single file. What could be easier than that? Applications written in Go benefit from instant startup times and fast performance. Unlike Java, JavaScript, Python, Ruby, etc., there's no need to load up a virtual machine or interpreter, so they're able to start instantly. Go's performance and concurrency take full advantage of modern multi-core processors to easily write applications with great performance. Are you sold yet? But wait, there's more. There's a robust ecosystem built around Go CLI applications. Go.dev lists popular libraries and books to get you started. Learn.go.dev also has a workshop on building CLIs in Go. The most popular CLI library is Cobra, which includes a generator that effectively builds your application for you, using intuitive design patterns, including subcommands, parameters, and flags. It also automatically generates help, autocompletion, and documentation. When GitHub wanted to build a new CLI, they chose Cobra and Go, and the response has been fantastic. They joined thousands of companies and projects who have built CLI apps in Go.
To understand why Go is good for DevOps, I find this quote works well. Go was not designed to be an academic language. It was meant for large production systems, to quickly onboard many inexperienced engineers to a code base, providing continuity across the software lifecycle from development to production to maintenance. This is the essence of the DevOps movement and the adoption of site reliability engineering at Google. Before going further, I'd like to briefly talk about site reliability engineering, also called SRE, and DevOps. What's the difference? DevOps and SRE are two trending disciplines with quite a bit of overlap. In the past, some have called SRE a competing set of practices, but it's not so different from DevOps. To read more, visit the link at the bottom. The key thing is that DevOps and SRE are both organizational practices. Go was designed to simplify practices around developing software for the entire lifecycle. Given similar philosophies and goals, Go is clearly a match for DevOps. Let's go over 9 reasons why Go is good for DevOps and SRE. Mentioned interchangeably are all the practitioners, which include software engineers, site reliability engineers, systems administrators, operations engineers, and production engineers. As mentioned before, Go is made to be readable, designed for onboarding programmers to teams quickly. It strikes a good balance between expressiveness and brevity. Even error handling, an oft-critiqued aspect of the language, has benefits of this explicitness, as particularly for when those errors hit programs running in large production systems. A small but strong standard library. A smaller footprint makes it easy for learning, developing, and maintaining software across the stack and lifecycle without getting bogged down in choice. As mentioned in the talk on CLIs, Go has minimal runtime dependencies. If you're a systems administrator, operations, or production engineer, you don't need to worry, as all runtime libraries are included in the compiled executable. So you can distribute your app the way you would any other statically linked binary. Speaking of binaries, you don't need to worry about what version of Go is installed on your systems, or even if it is installed on your systems at all if you're an ops. This makes it easy for doing migrations, upgrades, and deploys. It's great for these types of operation tasks. Also, if you're an ops, you'll often run into the chicken-egg problem, needing dependencies installed before running tools or scripts for your infrastructure where your app lives. Go is great for this bootstrap tooling where you don't yet have your dependencies installed. Garbage collection built in means that operators don't have to be burdened with memory management, making Go both easier to use and more reliable. Easy concurrency support via Goroutines. This is a first-class feature of Go and vastly simplifies distributed systems operations. Code bases today are becoming larger and larger, with huge amounts of concurrency due to networking requirements that didn't exist 20 years ago. Go is the right balance of trade-offs needed to solve modern productivity issues. It's the modern-day bottleneck for running distributed systems, which isn't performance, it's human cognition. Go addresses this human cognition issue without sacrificing performance. Go is also more explicit and better glue than shell languages. Glue refers to those connector bits of code you write to put your system together. The lack of data types in Bash or PowerShell start to come apart after 100 lines. For articulating more complex scripts for your infrastructure, you'll need something strongly typed. Use Go. And finally, Go is still very performant, particularly at scale. To finish off, there's a saying that software is never done. This is equally true for development and production and maintenance. Use Go for the entire software lifecycle and implement DevOps practices into your organization to improve your system and your business.
Developers love using Go. 90% of developers prefer to use it for their next project. Web applications are one of the most popular things developers build in Go, with half of Go developers using it for web apps. Go's concurrency, speed, and excellent library support make an ideal environment for today's web applications. Today, I'm going to introduce you to Go's cloud support, database support, web security, web frameworks, and learning resources. As is common today, many web apps are hosted in the cloud. Go has first-tier support on all major cloud platforms, including Google Cloud, Amazon, Azure, and AliCloud. This includes serverless offerings like Google's App Engine and Cloud Run, and Amazon's Lambda. And as you would expect, Go has great support for databases, from relational databases to document storage like MongoDB and Elasticsearch, time series like InfluxDB, and memory storage like Redis. All have excellent support in Go, and several are written in Go. Being a web developer is hard. You need to master everything from sysops, server-side programming, client-side scripting, visual design, CSS, and SQL, and all the other things listed here. Not only do these cross many paradigms and styles, but they're constantly changing. You also have to be current on the latest security trends. And even if you've done all of this perfectly, you also need to keep on top of the latest network, system, and container security. It should not come as a surprise that web applications are notorious for security vulnerabilities. Go is leading the way to better security and encryption with its secure by default approach. The latest encryption standards are written in Go, often ahead of any other language, and ship as part of the standard library. Google, Let's Encrypt, and Cloudflare are all heavy Go users for exactly this reason. Unlike other languages, Go applications don't just reuse the host operating system security libraries. For most web applications, the authors need to not only write a secure application, but also ensure that the host operating system is fully secure. With Go, the security is built right into the application, so it automatically supports the latest security standards independent of the host. Go ships with a powerful and friendly templating system. Among my favorite of its many features is the built-in sanitization. It understands HTML, CSS, JavaScript, and URIs, and automatically sanitizes any variable used in these contexts. This built-in safety prevents most cross-site scripting problems. Go comes with its own web framework built into the standard library of Go. This is the most popular web framework for Go. However, if your needs exceed what the standard library provides, there are many web frameworks readily available, and Go's modular nature of favoring composition means that Go's web frameworks and libraries all play well together. Go.dev has a book, tutorial, library, and framework recommendations to get you started. Popular web developer projects from Smashing Magazine to Vote.gov to Bootstrap to Let's Encrypt all use Go for their websites.
Let's outline why Go is great for application program interfaces, or APIs. APIs allow the capabilities of one program to be used by another, and they are essentially tools for bridging businesses in all industries. Go is a language with a formal specification, and it doesn't have undefined behavior. The API behaviors outlined in the spec can be read in under an hour. So even if you're new to Go coming from another language, you can most likely know what an API definition does in very little time. This specification or spec extends to decoding third-party or non-standard library packages. Speaking of third-party packages, Go is simple enough that if you want to find out what's really going on in some unfamiliar code base, you can. And often that's by inspecting the code itself. This simplicity allows for quick building all over the Go ecosystem. With the Go package discovery site, which you'll learn about in the Go ecosystem session, finding which packages and APIs are best for the job is easy and an almost trivial task. For those of you interested in specifics, Go is simple yet robust for containing all the primitives you need for APIs, including strings, lists, maps, and concurrency. I'd like to focus on concurrency here. Concurrency describes the concept of running several tasks at the same time, and this can either happen in a time-shared manner or parallel if you have multiple cores. For APIs, concurrent programming is a very difficult subject, but in Go, we have concurrency built right in as a first-class feature of the language. This is important for some types of high-level APIs, like streams, and the native concurrency is a big deal for APIs on both the server and the client side. Right balance for all APIs. If you care about low-level or performant APIs, Go can help you with bare bones, but also is complex and heavy enough to be useful for high-level APIs, especially ones that come from object-oriented languages where everything is boxed and there's a heavy use of generics. Also, there are multiple paradigms for APIs, including REST, RPC, and GraphQL. Go maps well to encodings like JSON and protocol buffers. And the 1.0 compatibility promise meshes well with API consistency over time. In conclusion, Go is good for APIs due to simplicity, a small but strong language, for easy onboarding and compatible usage across paradigms, robust built-in functionality, particularly for concurrency, and a thoughtfully designed middle ground between systems and high-level APIs.